Hello everybody and welcome to my first educational video on YouTube. Honestly, I've been wanting to teach for a while and I'm just now getting around to it, and my whole goal is to try to just make complicated things easier for people who either are just struggling with it or don't have the greatest teacher. I know personally, I have not had the greatest teachers growing up, and I immediately went to YouTube for my remedy, right? Anyways, enough of the intro. Let's just read the problem. A solution is prepared by dissolving 60 grams of KCl in 250 grams of water. What is the vapor pressure of the solution if the vapor pressure of water is 23.76 mmHg? Our first order of conduct is figuring out what do we know and don't know. Alright, we can see this right here. What we know is the pure vapor pressure, how much KCl we have, and how much H2O we have. What we don't know is the vapor pressure solution, which is what we're going to be solving for. Now, one thing before I continue, this pure vapor pressure, if anybody's wondering how we got it from the fact that we have KCl and water separated. They're not yet a solution. So we have the solute and the solvent. Water is typically your solvent unless it's stated not to be, and if it's two things that, don't include water, then it's whatever is in the bigger size. But besides that, this is our solvent, and this is before their solution, which is why it's pure. Now anyways, what we're going to do to find this vapor pressure is we're going to take our Raoults Law. Now Raoults Law is vapor pressure of the solution is equal to mole fraction of the solvent times vapor pressure of the pure solvent. Now, if you do not know what mole fraction is, do not be scared. This is the formula to mole fraction. It's actually way easier than it first seems. What it is mole fraction is equal to your chosen mole of choice divided by the total moles. In this situation, it's going to be mole fraction of the solvent, so we're going to have our solvent on top. Now, what we need to do first is we need to convert these grams over to moles, which the molar mass found in the periodic table is right here. I'm not going to do the entire equation of the grams to moles, but if you do have trouble with, figuring out grams to moles, I recommend going and learning stoichiometry before continuing to this, and then come back to this video whenever you figure out stoichiometry. Anyways, when you compute and calculate these numbers, what you're going to get is moles of KCl is equal to 0.80, and moles of H2O, water, is equal to 13.9. Now remember, our units are moles, which is right here. Now what we're going to do to convert the mole fraction is we're going to denote it with X of A is equal to 13.9 moles on top, and then our solute plus our solvent. Now do not forget this I. This I is very important. It is Hof's factor, and if you forget it, it will throw off your entire calculation. Now, what Hof's factor is it's going to be the amount of ions in an electrolyte, that or a polar molecule, which is typically an electrolyte, but a metal and a non-metal, right? Now, we're going to plug that in. We got 0.80 with a Hof's factor of 2 for KCl. KCl. Those are our two ions, and we're going to add that to our 13.9. Now, when you write this out and you actually calculate it, your end number should be 0.897. This is your mole fraction. Now, we have everything we need to get your vapor pressure of a solution. So we're going to take Hof's factor here. P solution is equal to your mole fraction right here, 0.897, times your given, which is your given pure pressure, which, as we said in the beginning, is this little guy. Since it's given and it's pure, this is going to go right here, and once you multiply that, you calculate it, you do your thing, you're going to get 21.3 mmHg, because this guy is mmHg. That is how you'd use Raoults Law. Thank you for watching. If it helped you, please leave a like. If you have any questions, comment down below. If there's any criticisms that I could do to improve the videos, please do comment that as well. Thank you for watching, and make sure you hydrate and have an amazing day or night. I'll see you guys around.